Good morning. It is my favorite day of the week, Baby Friday, aka Thursday. For those of you who have not caught on to the phenomenon of Baby Friday, it is the soft close to another week. I think my sound is on. It looks like my picture is good. At the very least, we are recording something for the masses. We're sending it to the masses. You've made it to the OscopeWizard show. I'm Gabe, the OscopeWizard. Thank you so much for joining me. We're going to hang out for a little while today, nerd out about, well, in this case, we are on a quest. If you've been following along, we have a quest that we are doing. It is a quest to build a DIY Sonos Style audio amplifier. So a do-it-yourself audio amplifier. We're making it out of, well, we have a box that I bought off of Amazon. We have various assorted amplifier boards that I bought from eBay. A couple other boards that I bought from eBay. Raspberry Pi Zero, W, and a power supply. And we are combining all of that, hopefully, to make something an audio amplifier. The something is an audio amplifier. To make an audio amplifier that will generate noise for my ear holes. And I hope it generates beautiful noise and not bad noise. On the last episode, I struggled a little bit trying to put together a rotary encoder to control the volume. So let's begin where I ended the last episode. On the last episode, I had a rotary encoder plugged in to the front of my box. And you can see I have upgraded the rotary encoder already. And I have a volume knob attached to it, or a knob attached, just a knob. It's just a knob. I just think it looks a little bit more swanky when you start putting aluminum knobs on things. That kind of gives it that extra bump to make it look super cool. But the knob does turn the rotary encoder inside. And if I was to show you, well, let's see if I can get over to my desktop. So here is the Mood Audio web page, and if I turn my rotary encoder, look, I can make it go down, so that's the volume, and I can make it go back up. And clockwise is volume up, counterclockwise is volume down, which is good. That is good. We had a moment of ah. Thankfully, I got it all sorted out on the episode. On Tuesday, I had the wires reversed so that clockwise made the volume go down and counterclockwise made the volume go up. That's sort of like if your shower spigot was connected backwards and the hot water was coming out of the cold faucet. That would be a fail. So we solved that problem. Now, I want to get into the music portion of the audio amplifier. So in the back of the audio, so I have it in this pretty cool box, which I'm pretty excited about. And I'm gonna unplug it and show you the back of the box really quickly. So in the back of the box, which I showed the other day, but not as detailed. So I'm gonna turn the camera a little bit. You're gonna see a little bit of the behind the scenes. Congratulations, welcome to the Techno Lair. I have a couple of speaker outs, so these are my speaker terminals, and I have a power cable connection to make it a little bit easier. Also, the all-important power switch, which was a necessary upgrade. Now, the box is sitting on the top here. I point this down a little bit so you can see a little bit better. The box is sitting on the top, and I have, I think, quite cleverly utilized some magnets to make it seal. So I put some little magnetic pins in the corner. Oh, well, you can't see that one because it's behind me, but I have some magnetic pins in the corner of the box, and those correspond to little holes right here, and inside of those holes on the lid are little magnets, and it creates like a mini seal, and I replaced the really flimsy hinges on the box. So, you know, nerd's gonna nerd. Nerds are gonna nerd. They can't help it. We can't help it. I'm with you. Nerd out with me. Okay, so now I have the speaker terminals connected, you can see, to the amplifier board in here, and I have my speakers. So here I got a speaker, got two of these guys, and I'm going to connect these to my speaker terminals in the back, and we're going to see what they sound like. And I know for a fact that I've got a little bit of a problem with noise getting onto the speakers. And let's explore that a little bit. So, just connect these. Well, I guess I could have shown you connecting them. Don't you hate it when people are doing a demo and they're doing the part of the demo that you want to see, and then they're like, but I'm going to do that behind a curtain so you can't actually see it. Well, there we go. We got it connected to the speakers. Knob's still working. Okay, speakers are connected. Let's power it back up. Turn it on. I heard a little bit of a pop, which is a good sign. That means the speakers are alive and ready to roll. The brutal truth of the Raspberry Pi Zero is it takes a sweet forever to boot up. So we're going to be booting up for a little while. Let's see if I can tell when it's finished booting. When it's finished booting, the web page will reload and be ready to rock and roll. Until that point, it will be bitter silence. Let me see. So let me see if the problem is already apparent, though. So the problem is apparent. All right. I'm going to move my microphone to the input of, or to the input of this, to the output of the speaker, to the speaker portion of the speaker. And I'm going to see if you guys can hear the noise that's coming out of the speaker. Nothing is playing. I mean, the Raspberry Pi is not even fully booted up. Nothing's playing, and yet there is noise coming from the speaker. So let's see if we can still follow. Okay, you can still follow. You can still hear me. It probably sounds a little bit different. Can you hear that? It's like a buzzy. It's like a buzzy, I don't know, a noise that an electric cicada would make. So imagine a cicada got electrified in some kind of weird dystopian future, and now it buzzes like that. So this is... I don't know if you can hear it. If you can't, I'll just describe it as the sound of electric cicadas, which is unpleasant. And I am trying to track down what is causing it. Now, on a positive note, if I do just play noise, so I'm going to I have my phone here, and I can connect to my Mood Audio AirPlay. So Mood Audio AirPlay is listed, I think. Let's see if I can see it a little bit better over here. Mood Audio, there you go, Mood Audio AirPlay. If I select that, and then I hit play, well, normally, there we go. So it does play audio. Now, unfortunately, when it is playing audio, this is something to tackle in a future episode. I no longer can control the volume with the knob, which is, I mean, I didn't buy that fancy aluminum knob to not be controlling that volume. So we got some software to be writing to try to figure out how to control the volume when it's in AirPlay and it's in Spotify, and I think even in Bluetooth mode. Right now, the knob only controls the volume when it's in this weird what do they call it? MPD, media player mode. But I want the volume knob to control the volume all the time. I don't want a selective volume knob. That would be a bummer. But when nothing is coming out, so nothing is playing on the speakers, no sound is coming out, I still have noise like angry electric cicadas buzzing. And what I've noticed is the noise you'll see there's my old Raspberry Pi. I'm going to pull my camera. Here, let's do it so you don't get motion sick while I do it. I'm going to pull my camera off so that we can actually see a little bit closer. But I think this will show it. Yeah, okay. So right here is an LED on the Raspberry Pi, and it is brilliantly illuminated right now. When that LED is illuminated, indicating there is CPU activity from this CPU right here, which is really tiny, and it's amazingly tiny. When that LED is lit, illuminated, noise, like the angry cicadas, electric cicadas, comes out of the speakers. It is a very low noise. So initially, I thought, I'm going to try to attack this from a hardware perspective, meaning I'm going to explore my design a little bit, explore the speaker outputs, explore the power supply. Power supplies are generally where noise is coming from, but I suspect it's actually coming from the Raspberry Pi itself. We're going to see if we can tackle that noise problem. So on the oscilloscope today, I have a couple of probes. I have my trusty power rail probe there in the middle on channel 2. I have my huge differential probe on channel 3, meant for looking at kilovolts of differential. And then I have just a regular old passive probe on channel 1. And I'm going to probe different sections with the different probes to try to determine what might be the cause. So let's start by making a couple of connections. I think some of the noise might be coming from the power supply. So on the Raspberry Pi, there is a handy 5-volt output, which I am using right now for the rotary encoder. But you know what I also have on the Raspberry Pi is the 3.3 output. So the 3.3 volt output is the voltage rail that I'm using to power my DAC chip. So here's my DAC chip. That is being powered from the Raspberry Pi via the 3.3 output, and then the audio signals, so these are the analog audio signals, are being routed into my amplifier. Now, one way that I can remove the angry cicada buzzing is to actually disconnect the analog audio from my DAC chip. So let me make sure. Angry buzzing, angry cicada buzzing, still happening. I disconnect. Ooh, you could hear that big time because I pulled my ground off, and so suddenly the amplifier ground reference was all over the place. Now it's like super quiet. I'll put my microphone right up to it. I mean, it's so quiet it doesn't even trip the microphone's gate. So that is, I don't know why I'm talking into the speaker. Don't talk into speakers. But it is super quiet. So when you disconnect the DAC audio input chip, it is not making a noise, which is a good sign, honestly, because that means the amplifier is not creating the noise itself. If the amplifier itself was creating the noise, that would be real problematic for me to solve. But that noise is coming in from an external source. All right, let's see if I can get this all squared away. There we go. Oh, now I've made it really angry. Okay. That was one way. Let's see if the angry cicadas are still there. Angry cicadas are still there. Angry cicadas are still there. So let's see what the output of the speaker looks like. So I have the speaker outputs right here, the terminals of the speaker. If I zoom in on those, one of the things I could do is just connect up my differential probe. So I have my differential probe my ZHD. I'm going to connect it up to my speaker outputs and just take a look at that speaker. I'm going to try anyway. So, nope. Negative. Oh. Negative. All right. Let's use the actual speaker wire. Put it to good use here. So we'll leave some speaker wire sticking up. And that pulled it right out. You know what's good for measurements? Long, skinny wires. Proven to be awesome for measurement. That is facetious, folks. You want, I think we've actually gone over it on the show before, as short a wire as possible. Okay, can I get the second? I have the, these probes are not the right tool for the job. I've also gone over that. I'm using the biggest probe I have. It's gigantic. It is frankly out of control, and I'm fighting a bit of a cold. Sorry, excuse me while I use a tissue in front of literally hundreds of thousands of you. Okay. Now I have my, you know what? While I'm here, I'm going to also plug my power rail probe into my 3.3 volt rail so we can look at both the speaker output and my 3.3 volt power supply. You can hear them, like as I move cables around, it's real touchy. I'm just wondering, I've really done some stuff now. Okay, speaker. I'm wondering if it's going to be down to these long skinny cables that I'm connecting the GPIO to the DAC with. Oh my goodness, look at. Okay, so so now I'm going to switch over to the scope so you can actually see what I'm doing. So here we go on the scope. First of all, before I get too deep into the scope, I need to preset the scope. I'm actually not looking at channel 1, but I am looking at channel 2, channel 3. Channel 2 is my power rail probe. So let's go over here and turn on my probe meter. That'll let me find my power rail. I'm looking at the 3.3 volt power rail, which is a good sign that the probe meter tells me that it's 3.3 volts. So there's my power rail probe. And I'm going to close my probe meter. And here's my differential. So channel 3 is the speaker output. I'm just connected directly up to the speaker output. I have the scope set up to be 10 gigasamples a second. You can see my speaker output is being monitored at 200 megahertz. None of that makes any sense to me, so I'm going to lower this down to something that your ear holes can hear. So I'll make this 50 kilohertz, which is super duper low. And then I need less sampling. I don't need 5 gigasamples a second. I could do 1 megasample. Or I could just do, see what the min is. Oh, acquisition time. I need more time. More time. Sample rate. Is that because I've done something weird? There we go. Oh, I have this auto adjustment on, and I have my record length set to 10 megasamples, which should honestly be plenty of time. Okay, so here is the noise. Does it sound like angry cicadas still? Let's see here. Still sounds like angry cicadas. Now, as I move if I just literally move my, you can hear it kind of, well, I don't know if you can hear it on the speaker, but you can definitely see it on the oscilloscope as I move wires. So I'll move wires, and you can see it on the speaker output bumping around, which isn't really that unusual. I mean, that would be like you plugging in a cable. When you plug in a cable, it's going to make noise. That's just part of it. But once you stop plugging in the cable, you would like that noise to end. So let's do an FFT of channel 3. And I am interested in the FFT portion from 0 to, I think we have 50 kilohertz set for my bandwidth of my oscilloscope. Yep. All right, so let's make the resolution bandwidth 100 hertz. So that makes the steps of this FFT, each individual point in this FFT is tied to a resolution bandwidth bin, and I want a lot of bins, so a lot of points on this line, so I can get a little bit more detail. And then I want to turn my memory down because I don't need that much memory. I need a minimal amount of memory. Look, I turn my memory down, boom, we're going real fast, real fast. But look, you can see it popping up and down like that. Channel 1's going crazy, but it's not plugged into anything. I'm going to close that out so it doesn't bother us. Channel 2. So this is the FFT of channel 3. I can see noise. I'm going up to 50 kilohertz. So up here at the 50 kilohertz point, or very near 50 kilohertz, I think what we're seeing is a switching power supply. Right, just this big broadband noise through this section is definitely going to be in the audible range, and it's definitely going to sound like angry cicadas, is what it's going to do. I also have a peak down here, which is a little disturbing. Okay, so let's just check out the power supply really quickly. So this is going to be my 3.3 volt power supply. I need to zoom in a little bit more so we can see more detail. So this is my power supply over here. It's on my 3.3 volt rail, which is the thing that is driving my digital analog converter chip, which is where the noise is being introduced to the speaker. So I'm going to do an FFT of my power supply. And this FFT has gotten crazy. So did not do that right. Let's set this one up the same way that I did the other one. So 50 kilohertz, 100 hertz resolution bandwidth. So DC to 50 kilohertz, 100 resolution. And let's turn the record length back down because I don't need that much. There we go. Now my scales are a little bit off, so you can see my max on Math 1 is to 5 dB. Let's put these beside each other. Wake up. Is that going to work? Oh, you know what? If I did it right, it would work. Let's put it right here. All right, so Math 2 and Math 1 are beside each other. These guys, let's change my max so that I want them to line up. I want these two lines to line up. So, look, it does not appear as if the power rail is the problem. I do see these broader band jumps, but look, my scale is like minus 69 dBm, which is really low. The speakers themselves can see stuff at like minus 90, minus 93 dBm. That's how tiny of a signal the speaker can detect. But this signal is way up at like minus 45 dBm, which is like in the wheelhouse of the speaker. It's going to be a quiet sound, but a sound nonetheless. So, let's see if we just change power supplies. Does it help at all? So I'm going to go back, and instead of using, so I've been using this DC to DC converter that I purchased off of eBay for like maybe $2, maybe look, if I tap it, I hear noise on the speaker, but of course that's going to be just like tapping the wire. Okay, so if I replace the DC to DC converter with a different, wait a second. Oh man, I just knocked the wires around a little bit while I was talking to you guys, and look at the scope. The noise is way down. Look at this. I am having some kind of a coupling problem with just the noise of just the wires' proximity to one another. Do I have angry cicadas? The angry cicadas are gone. Could I actually play noise? Let's see if I could play noise to my amplifier. Okay, now it's like, now if I pause it, the power supply is going a little bit bananas because that power supply, the Raspberry Pi power supply is very noisy. You see all kinds of digital traffic on the power supply coupled in. It would generally be considered a wild design, but it works. And I mean, the Raspberry Pi Zero costs what, like $5? So let's not be too hard on it. But no more angry cicadas from my speaker. And that is from bumping the wire. So I bumped this wire. This is the analog audio signals from my DAC to my amplifier, and that cleaned up the noise. That means, so I bump this around, oh, look at this. My noise is back. I'm definitely getting some coupling there. So I might need to do a little soldering to make a very short wire from my DAC to my audio amplifier. So one thing that I could do is I could pull out the adapter right here. Let's see if I can see it. I can pull out the adapter that's on the amplifier right here and connect it directly with some pins to here. I could flip this around and then just solder it directly with a minimal amount of wiring. I think that might be the solution to my noise problem. I think it really is just like, there we go, no noise. It could just be a loose wire. It could just be a loose wire that I'm like, these push-on connectors could just be loose. So maybe what I need to do is just do some soldering. Now, before I solder it, I do have this plan to have an external audio input on this amplifier. So maybe I need to solder from this board to here and from this board to my input, or just use the audio jack that's on the DAC there to go to this board. But maybe the next step is to try to get my switchable, yeah, because I can see if I touch it just a certain way, the noise goes away. So now if I go back to my scope, no noise. Connection problem, guys. That was my noise problem, a connection problem. I am going to be honest with you. I struggled with this for quite a while yesterday. I think I probably spent 2 hours trying to track down this noise problem. I had an extra little DC to DC power supply to try. I had USB adapters to try for the 5-volt from the scope. That cleaned it up a little bit. Ultimately, what was happening as I was plugging in these little accessories, I was bumping the audio cord from my DAC to my amplifier and cleaning the audio up, basically probably getting a better ground connection between the DAC chip and the the audio chip over there. So, you live and you learn. You live and you learn, folks. I am still learning. I won't even do the 5 minutes remaining because we're long past 5 minutes remaining. We're pushing into negative 5 minutes remaining. So I really appreciate you guys joining me. Let's go back. Let's wrap it up. I really appreciate you guys joining me. I'm really happy that I was able to diagnose the noise problem. It looks like I have a little bit of soldering to do in my future, so I'm going to put a proper connection between that DAC chip and the audio amplifier, and I'm going to stop using those kind of loose jumper cables, because I think the loose jumper cables that I was using, these wires like this, you can barely see it like that, were causing the noise. It was not properly seated on that ground pin, and when the digital audio converter, the DAC chip, and the amplifier do not share the same reference. So normally they would all be on flat ground. So let's pretend this is my ground plane. If one ground plane is up here and one ground plane is down here and they start shifting back and forth, that, ladies and gentlemen, is going to cause noise on my speakers. And I believe that is what was happening. So my ground reference planes were shifting back and forth. Live and you learn. OscopeWizard. Here we go. We're wizarding. In front of everybody. Here is the magic of electronics. It all comes down to solid reference planes. That is actually, in your engineering design, solid reference planes, super key. When I designed printed circuit boards for a living, it was very important to have a very large ground plane so that current had a really easy time getting back to the beginning. You don't want to give the current trouble, or the charge, I should say, the charge trouble. You have wasted another half hour nerding out with me. I almost went into Click and Clack the Tappert Brothers, but I won't steal that from them. But I really appreciate you spending this Baby Friday with me, the OscopeWizard, here in the Techno Lair. I don't know all the nerds in the world, but I would love to meet them. So share this with the nerd in your life. And I will see you guys next week. Next week, we're going to have special times because I got to accommodate life outside of the OscopeWizard. So we're going to have some special times. But don't worry, if you go to youtube.com/OscopeWizard, you can see the show listings and it will have all the appropriate times, and just jump on. And if you don't jump on, don't worry about it because everything is archived for you. I appreciate it. Thanks for watching. Take it easy, guys. Bye.